There's like a few seconds, 30-second lag, 20-second lag.
That too. Well, Microsoft with holographic display.
Yeah, the HoloLens.
All right, good. It's up.
Good. So we're gonna start at.
Start at 3:30. Well, you want to wait here and have the camera here?
Yeah.
Okay, great. Have fun.
Awesome. Well, I mean, about 10 years that have goals as well. So, like, thinking about a certain app to launch it.
So there's a lag, but you'll see your hand move.
Self-driving
Or
cars.
chemical things.
Oh, there's a lag.
Like release this funny dopamine.
That's funny. Is that live right now for
Yeah.
remote students?
It's coming,
Yeah.
man.
There's
It's a
4.
question of like whether we're gonna be on the resistance side or like try and steer the process, I guess, or it's coming either way.
Yeah, it's definitely.
That's a lot of lag. I didn't know how to do that.
Yeah.
It's kind of cool.
Self-driving cars.
Oh god, Elon Musk today was
There's
talking
3
about
students
already
watching right
the
now.
Model S
Good. Okay.
updates now.
Well, in 16 seconds they're gonna laugh.
Only on private property, if GPS detects that it's on a public road, it won't do it for regulatory reasons. But if it's GPS detected that it's not on a public road yet, it uses sonar to find its way around objects as small as a fist and as fuzzy as a mouse. So it's a rule where you think like it knows better than a human being with 20/20 vision, like where everything is and cars and their own car.
He's a smart guy.
Musk is a fascinating character. The whole family, like, they're all famous entrepreneurs that
Yeah, another. He's got SpaceX. He's got the car out Tesla. He's got a solar panel company. I thought I heard he was trying to sell that.
How are you doing
So he did this solar panel company over his cousins. His cousin like started an essential oils company on his birthday when he was 16. Came to California from a pure water oxygen tournament. Was like, I really like California. So he goes back at 17 years old and sells
Is it like more
essential oils company in California and his cousin Elon Musk.
Yeah, it seems.
Cool.
I think it's
Here's a solar company. Like, I don't have time to run it, but here's $10 million. Like you run it. And he did. That was what Solar City did.
Yeah.
So it's just like their character is that.
How did you hear?
Steve Jobs invented Worldly, and like
How did you hear about the solar? My friend Grant.
but like super intense.
Well, no, Jobs, it was just reality distortion.
Yeah, they don't quite match that. That's a very
The amount of time you can have it in last like 2 hours.
What I really have you love to drive Tesla.
From Portland?
I'm not. I'm from Alaska.
Yeah, I guess for Chase, there's a company called Zero Cycles now.
Were you living here?
I was living here. I've been here for like 3 years.
Oh yeah.
Yeah. I grew up here.
How did you hear about
Do you
that?
want to?
Online. I was looking for a job on Craigslist, and then I was like, this looks interesting.
Yeah,
And I
they
was
got
like,
fuel drivers now. It's funny because I was watching videos.
like 4 years.
I'm not even kidding you. Like in the firmware on the dashboard, it's
What?
like normal, turbo, and insane. And if you switch it to the zoo, it's
That Oregon is doing, where you get a free I started doing that. His grant was doing that as well. If you are trying to prove wrong, treehouse classes. Here, his job. It's online.
oh, right.
Yeah.
Like an actual group called
No.
Weird Group.
Not
yet. No.
Their teaching style, I feel like, is very used to like have a lot of hierarchy. Like, I felt like I was learning things as I was going through the program, but I wasn't retaining much because I was just
They say it's not waterproof, so just run the range with it.
Awesome. How did you start getting interested in this?
Yeah.
That's how I started. I feel like it's always been interesting to me. So like when I took seriously, I had a class in school to learn HTML. I love this. And then I went to college and got a degree in literary studies and have since discovered Mason status.
Yeah.
So I've been interested in pursuing
How's this looking? Is it still working?
Yeah.
Yeah, like some stuff works really well.
All right, guys, let's get started. So what I need from you is, in about 10 seconds when it actually gets live to where I am, tell me if I'm in frame really well.
No,
okay?
you're good right now.
Okay, we're actually live streaming this to our remote students, which is the first time we've done this, so that's kind of fun. I mean, we do screen shares and everything with them all the time, but first time they get to watch me almost live. There's about a 15-second delay. So anyway, welcome to the Tech Academy. Thank you very much for being here. And I want to jump right into what we're doing here. My name is Eric Gross. I'm the founder of the school, and today we're going to be talking about information security. I do have a little handout for all of you. It will be arriving within the next 30 to 120 seconds. Man, I'm geek. So, first thing I want to do is just talk about what is information security, and you're going to have these notes in your hands in a moment. Anybody here ever work in information security, technology security, that kind of thing? Okay, good, all right. So this is a long Wikipedia definition, and we're going to break it down a little bit. But it's this: information security is the practice of defending information from unauthorized access, use, disclosure, disruption, modification, perusal, inspection, recording, or destruction. It's a general term that can be used regardless of the form of the data may take, i.e. is it electronic data, is it physical data. That's what information security is, keeping your information secure. Now, there's a lot of different ways information can be insecure and what can happen if you don't protect yourself. And some of the threats that are out there are ones that we're kind of familiar with just from being denizens of the interwebs. Because you hear about phishing attacks and viruses and all this kind of stuff, but a lot of them aren't so common sense. And so we're going to go dig into this a little bit. Along the way, we're going to cover what kind of precautions or knowledge level should a typical employee have, and also what should a developer have in his toolbox. What should he be thinking about as he does his job? And surprisingly, it isn't all about the code. It isn't all about how you're writing your code. In fact, most of the factors involved in best practices for security have to do with people rather than the code, but we'll get into that in a little bit. So, a couple different things here I want to cover. What are the kind of threats that come from, come to information? Like, what are the things that can happen? Well, there's typical things like loss of intellectual property. Who knows what intellectual property is? Okay, well, give me a definition in your own words. What does that mean?
Well, like I said, if you were a writer and you were writing a book and you had your manuscript stored online and someone took it and copied it and made use of it.
Absolutely, and it can be like that. It can also be things like, let's say you're Amazon and you've worked out a tremendously efficient algorithm for getting physical goods off the shelf and onto the shipping lines and out the door with as little use of human beings as possible at the lowest possible cost. The way you did that is hard-won knowledge, very, very valuable, and you're going to want to protect that kind of thing so your competitors don't implement that. Does that make sense? Okay, good. So that's information. That's intellectual property. It covers a lot of different things. It can cover software. Software and how it works is intellectual property. Business practices are intellectual property. So theft of intellectual property is the matter of information security. That's one aspect of it. Other things are theft of actual equipment. If you have, for example, an iPad at your house that's the latest generation of iPad that hasn't been released to the world, and you get stolen from your house, as happened a few days ago down in I'm brain farting on the town, Cupertino, Apple's from. So this guy down in Cupertino, someone broke into his house under dubious circumstances, took an iPad. Now we don't know for sure whether that iPad is like the latest generation the street hasn't seen or not. But Apple's got a history of that. They have a history of people that have these real cool prototypes kind of accidentally leaving them somewhere they shouldn't, or having someone break in and steal them. How valuable is that piece of equipment right then? Its value isn't just, ooh, how cool it is to have a prototype. It's the loss of business that could happen because of that. It's the trade secrets of how it's built. All this stuff falls under information security. So again, you can see that a lot of it isn't just how you do your job as a software developer, right? Other areas are information extortion. How many of you have heard about this thing where someone will actually hack into your computer because you download some kind of really helpful software that isn't helpful at all, and it locks up vital files, and then you get an email that says, hey, these are locked. If you want to unlock them, wire us $200 via PayPal. Anybody ever heard of that happening? And that's happening right now. They literally hold your information hostage. And if it's vital documents that are business related, you're screwed. But if it's like personal documents, all banking records, all this kind of thing, you literally can't get into them. And because a hacker has actually made it so you have to send them money, and then they'll send a security code to release that so you can get in. So information extortion. Not a lot of fun, is it, right? And finally, software attacks, the things we've heard of, things like viruses, worms, phishing, Trojan horses. You hear all these things thrown around. Now, the exact difference between a virus and a Trojan and a phishing attack and all that, not the scope of this kind of talk. You can dig deep into those kind of things. But the point is that all of them are designed to be able to have someone with a nefarious purpose get your information. And again, it's nefarious. It isn't goodwill. Now, one point I want to make is that not all attacks to try to get information, vital information, are nefarious. Not all of them are, have ill will behind them. A really well-known example was the subject of the film Imitation Game. How many people saw Imitation Game when it came out about 3 or 4 months ago? Imitation Game was about Alan Turing. Anybody in the audience know who Alan Turing was? Okay. You are all going to be geeks pretty soon when you graduate, and you need to know who Alan Turing is. Alan Turing is one of the sacred fathers of the computer industry. He lived in Britain from about 1915 to about 1954, I think, when he died. And he brings a lot of things to our industry. One of the key things is that during World War II, he and his team managed to break a code that the Nazis were using to encode all of the messages that went around the world while they were busy decimating the Allied forces. It was an incredibly good code, very, very difficult to break. And his work to actually break it produced some of the thought process and machinery that underlies all of computing nowadays. He also went on to produce things, experiments in artificial intelligence and how is it you can actually create a computer that a reasonable observer who's interacting with it might think is actually a human being, right? So Turing is a tremendously fascinating individual. I highly recommend you learn about his work. But it's that thing that happened in World War II that's an example of the fact that not all these attacks are ill-willed. They were trying desperately to decode the encoding encryption the Nazis were using, because every single day that they didn't, people died. And they did succeed. And again, this is all a matter of public record, open over in the movie for you, but even when they solved it, the scene is fantastic in the movie. When they solved it, they still couldn't tell anybody, because if the Nazis knew that they were de-encoding all of their communications, then they'd switch to something else, and they'd be back at square zero, and they'd be toast. So fascinating story. You should look into it on your own. But the point is that information security, when you're using it, there's almost are you a white hat or a black hat kind of mentality, right? And in fact, some of you may well find yourselves in your career as a developer in a role where you are a bit of a white hat sort of person, meaning that you're going to go in there, you're going to deliberately try to break into something, trying to violate all these protocols that are put in place to protect information because it helps your organization to do so. So let's move on. I thought that was kind of neat that not all the guys that are trying to break into things are bad. Okay, so are these? Danny, can you check on the handout, please? I wanted to get these printed. And I know we have the slowest printer in the known universe, but I got nothing here. If we get some of them out, then people can at least have some. Okay. All right. So the field of information security has grown and evolved a lot over the past several decades. And there's a lot of ways you can get into it. I want to tell you several different areas about it that you can think of as you're looking to your career as soon as you leave here. Things like securing networks. you have all the internet, as many of you know from going through the program here. The internet and the web, first of all, they're not the same thing, but the internet is interconnected networks. And if you can get your computer that you want to do harm with connected up to a single network, well, now you could potentially access millions of other computers because you can hop from one network to the next. So securing your little, like if you're a company and you open yourself up to the internet, you are automatically subject to a lot of attacks. It's just going to happen. So if you're like an Acme Inc. and you are in charge of information security, you have your network. And if you were isolated from the world, that'd be great, but you're not. You've got these wires that connect you to the whole world via the internet. And your job is to make sure that this little sort of walled, sort of protective area that your physical machines are in is safe. That right there is a very, very important specialty. You're not building software. You're not dealing with people and process. You're protecting physical hardware because that's how they get in to gain access to your information. Make sense? Okay, good. So other areas, securing applications and databases. I was working at IBM a few years ago, and they have a special company out in Beaverton that IBM bought that is a mortgage processing company. They handle all of the financial records for people that own property. Things like, what are the different taxes that are due at the end of the month or at the end of the year based on what kind of property you have. I'm going to give it a minute until all this gets handed out. Good, awesome. Hi, thanks for waiting. Am I still in screen? This is good?
Yeah, you're good.
Okay, good. How's it looking on there? Pretty cool?
Good.
That's really neat. I love that I can still get excited about technology. Okay, good. All right, so securing applications and databases. So I'm working at IBM, and they have, 250,000 individuals for which they maintain mortgage records. And at the end of the year, they're responsible for if other people knew about that kind of stuff, right? So I'll give you an example of how this can be done well and how it can be done poorly. If it's done well, in terms of information security, you have databases that are used for the real, actual, like, in-use, live, they call it operations environment. And then you've got other environments you have to have. As we talked about a couple of days ago, you have to have a development environment, you have a quality assurance environment for testing, you may have a separate environment for user acceptance testing. Each one of those has its own set of applications and databases that should essentially be a clone of each other. Except you do not want the developers or the quality assurance testing people viewing the live data for Mr. and Mrs. Jones that are out in the real world. So you must encrypt that data. You must scramble it so that they can't actually read what it says. So that was done at IBM. Now, what was used was probably a 4th grade level encryption algorithm where all they did was take a letter, jump forward 7 letters in the alphabet, and switch it to that. Super complex. It would take any of our graduates about 10 minutes to write a cool little algorithm to go through and de-encrypt that entire database. In fact, one of the guys there did that on a lark. Not a smart idea. But the point is that you can put in place what you think are really, really brilliant processes, but you've got to try to break them. You got to think with like what's really going to happen when someone actually uses this. So the whole area of protecting databases and protecting applications is a whole career area for you guys to go into. Okay. Then there's security testing. So again, I said if you're going to build it and you try to build in some sort of protective mechanism, you better make sure it works well. Well, that's a specialty in and of itself. Is a developer whose sole job is to try to break things, to try to break into things. That would be the white hat. And it's a fun job. It's a fun job. Some of the best developers in the world are white hats. And they get employed for fantastic sums because you'd much rather have that security breach happen inside your facility when nobody knows about it rather than be Sony, whose entire dirty laundry and movies for the next 20 years get aired to the whole world, right? Have that data breach happen internally. And then there's a whole other area called digital forensics. Who knows what forensics is? You know, basic, go ahead.
Inspecting.
Yeah, okay, good, inspecting. Specifically, it's inspecting areas of criminal nature. Like a forensics examiner is someone who's actually examining the scene of a crime. Well, a digital crime doesn't leave, blood spatters and all that kind of stuff that we see on CSI if you're up late at night. But what it does leave is a trail. It absolutely leaves a trail. So I'm gonna jump ahead to a point here about being a good developer. If you are a forensics information security specialist, you need every clue you can to track what happened. For example, I would wager that millions of dollars were spent by Sony after that data breach. All joking aside, that was tremendously painful for them, cost a lot of money. I'm sure they brought in the best people they could and paid them tens of hundreds of whatever dollars to find out what happened, how did this occur, how to prevent it in the future. So when you're building an application, one of the key things you actually would put into it to help in this regard, among others, is adequate logging. At every step along the way, when you implement a process, call a function, do any appreciable unit of work, do you log that somewhere? And when you log it somewhere, have you built your logging system well enough that it goes back far enough in time, it can be stored long enough, that a forensics examiner who comes along afterwards can start parsing through those logs to find out, oh good, this is when the attacker made a web request. Oh look at the password information you put in there. He injected some code to let him break in. Okay, good. So at least we know how it happened. And then he'll be able to go, okay, where did that request come from? And jump to whatever, out on the internet where the guy was that made the request. The point is that when you're building the application, by using best practices as a developer, you're letting someone who comes along after you do their job better in the horrific event that somebody actually commits a security breach. Make sense? Okay, good. All right, so that's digital forensics. And by the way, fascinating field. Anybody who you want to have a lot of fun, just go onto Wikipedia or any other anywhere on the web and just type up, digital forensics horror stories, and you will find some amazing things about what it's like to actually try to track this stuff down. Some of the most brilliant minds, but they have to think like the guy who's breaking in. And by the way, that is one hallmark of a developer who does a really good job in information security, regardless of what role you end up in, is he thinks about what it's like to have that viewpoint of either a malicious user or a very poorly educated user who makes a mistake and then allows data to be released. If you think about those two kind of viewpoints, what would it be like to try to intentionally break in, or what would it be like to not really know enough about computers to use this software tool I made poorly and thereby allow data that shouldn't be released to the public or wherever to be released? If you think from their point of view, you'll write your software better. All right, so two different things. How does information security apply to the average worker? Not just a technology worker, but anybody. But what you want to know about as a worker is, what are the points of attack? Because if you're not going to be the expert. You're not going to be the guy that knows everything about how all this happens and how it is you protect your software and your databases and how do you protect your physical networks. You're not going to know that. But what you can know is people. And you can know the things that people do, the points of attack into an organization. Things like social engineering. Anybody know what I mean by that? Like, what is social engineering?
Bradley Manning used social engineering to leak those documents to WikiLeaks.
Yep, absolutely. There's a writer on Gizmodo. Gizmodo is an industry website that talks about gadgets. I'm there a lot, okay? And there's a writer on there named Matt Honan. Now, Matt Honan, about 2 years ago, had someone pretend to be him with 3 different separate places: Google, Facebook, and his bank. And in the space of about 45 minutes, by pretending to be him and knowing part of the information, but oh man, I don't quite have that with me, and he actually managed to get the people on the other end of the phone to give him vital information to the point where we could actually finally log in to bank accounts and also to iCloud accounts and wipe all of his data. Just utter destruction. Ruined all of his work for a year, but he wrote about it in detail, and he wrote about it from the point of view of, listen, I actually messed up, and here's how I did mess up. But that kind of happens. It's called social engineering. You might think of it as the ultimate con job. You can think of it as, what's that Catch Me If You Can movie? You all saw that, right? There are people who are quite good at getting others to believe they're another person. And if they can get, like for example, most people use the same password across all of their things. You get one, it opens up everything. Most people also use, most companies, when they're confirming your identity, only use the last 4 of your social. You can get that information relatively easily from a variety of sources. So if you take that, do a little bit of research, find out what the person's mother's maiden name was, you've got 20 or 30% of the most common data is going to be asked, right? So social engineering is doing that, pretending to be the person you're trying to cause harm to, and then getting into their accounts. Passwords. Have any of you ever seen these articles about what are the top 10 most used passwords in today's technology environment? Password with $2 signs. is still actually being used. Admin as a password is being used. And it isn't just that they're being used. It's amongst the top 10 passwords in the world being used. So if you are a developer, one, don't ever do that. Two, you're the technology expert. Any organization you're in, you're the expert in this area. If you tell people, hey, listen, you can't do that. It's just not safe. You will have more altitude. You can actually spread the word about this kind of thing because people do it. But to the point that I'm speaking of what should the average employee do, they should know some basic system for putting together passwords that doesn't have it used the most common things and where it isn't written on a little yellow sticky. there was the bombings in Paris 2 months ago now, right? The break-in that allowed that bombing to happen was enabled in part because in an article where they were interviewing one of the members of that newspaper, behind them on the wall, written on pieces of paper, were passwords. Yeah. Whatever, and this is just a personal thing, whatever system you need to come up with, you never have to write a password down, come up with it. Just, or use LastPass, which is awesome, right? It's a password, storage manager. But don't ever, 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 ever write them down. Don't ever do it. Okay, portable computers. Well, this is funny, I'm just walking to pick up my computer. It's my case. There's my computer. This is now a computer. It's not a phone anymore. I know we all know that, but it's a pretty important thing. What kind of data do you think you can access if you get a hold of somebody's phone? Like, most of us have it on our hands, in our hands all the time, or in our pocket, and so we bypass so many security protocols you wouldn't even believe it. Like, I can't believe I'm saying this out loud to all my streaming students. If you grab my phone right now, my LastPass app, my password manager, it doesn't have any protection. You could open it up and you could see most of the data about my accounts. To see the actual password, you have to put your thumbprint on it, and you can't have my thumb. Okay. But if you know all the places I have accounts at, and you're gonna do one of those social engineering things, you just have 30 or 40 different accounts to try to break into just from grabbing hold of my phone. So security on these things is stunning. So it's a thing to know though, as a regular employee, is don't leave these lying around. Protect them with a thumbprint or with, Android has a little trace, whatever it is. Don't think you're gonna have this all the time. If you leave it behind, you're toast. And if there's business data on there, you're double toast because you're not gonna be working there anymore. Okay, and finally there's things like wireless computing as a factor. So this whole thing about networks, it's really wild what people can do when they get creative in their ability to hack into machines. All of us right now are standing in a constant stream of radio waves going all around, and any one of those, anybody who's talented with both hardware and software can isolate the one that connects to a specific router. If they hack into that router, again, they can have access not just to the internet, but any unsecured machine on the internet, anywhere in the world. So if you are in your job connected to wireless networks in any way, shape, or form, it's your responsibility to make sure that they're adequately secure. I still find downtown, you go downtown, you go to Starbucks and you pop up, you're looking for Wi-Fi, and you'll find business Wi-Fi accounts that aren't password protected. Like, really? Okay? Well, anybody at that company would know that. Because I guarantee they've all walked into work with their iPhone or their Android and said, I want Wi-Fi. And they log on and they find their companies and it doesn't have the little lock symbol next to it. Do you say something at that point? Well, yeah, you do if you've got some awareness of this problem and you care about your company. Okay, now, how does information security apply to developers? So, it doesn't just mean building software that protects against common technical attacks. Software is a tool used by people, so most of the best practices a developer will need to pay attention to relate to people, not coding. So, I'm not going to go into each one of these in detail, but I want to give you a little background on what I mean by each of them. So, protecting your brand. How devastated do you think Sony is? How much damage was there in the public eye? And Target. Target, it's horrendous data breach. And they make news all over the world when this happens, right? what happens? Well, you can recover from it, you pay a fine, and this, that, and the other, but the point is that for decades afterwards sometimes, your brand is harmed. And I can tell you from the work we're doing here at the Tech Academy, building up a brand, an actual reputation amongst a large enough group of people out in the public that you are known a certain way, it takes a tremendous amount of work. And every single individual in a company actually creates that with their actions every single day. You add up all of that work over decades, the amount of goodwill that's generated, and it can die in one incident. It can die in one breach of data. So why be concerned with this as a developer? Because your company could go under, from a very pragmatic standpoint. But the point is that when you're thinking about information security, realize that you're not just protecting data, you're protecting your company and its future survival, which is a pretty important thing to protect, right? Okay, so another factor, know your business. Not every single business domain, if you will, operates differently and has different factors involved in what does information security mean. There are businesses that never see the public. They're purely business to business. They don't have any actual, brick and mortar storefronts. And there are places that are completely the other way. They have brick and mortar storefronts, like they have, Sprint, for example. Every town in America has got a Sprint store. The way the companies have to think about security is completely different based on what they do. I see this quite often as a software developer. You go on contract and you're there with other contractors, and they want to jump right into coding, right into building an application. There's nothing wrong with that. You're there, you're eager to code. But the fact of the matter is, if you're not designing and coding with due regard for the business process that your software is meant to support, and the security factors related to that business, you're not doing your job very well. You need to make an effort when you get on the job to understand the company and everything about how it does business. What are the things that are its strengths? What are the dangers to the company? Who are its chief competitors? What are the points of attack that a company could have? Not like you can make a big old giant investigation into this, but you need to know your company and what it does and its business process. Because then when you code, you can do it with that in mind. And there's so many opportunities you'll have to make design decisions about your code that will be different based on how your company does business. So think about that. Okay, understanding the technology of the software. All right, now what does this mean? That means you arrive on the job, and unless it's a brand new startup, they've got between 10 and 50 years worth of technology already sitting there. And it's a big old mishmash often of 20 different technologies, and this language is used there, and this physical hardware is used here, but then it was replaced with something else, and that fell apart, so they had to go back. And the point is, it can be a patchwork quilt, which is a security nightmare, by the way, because there's no one overall way you can enforce security over the whole thing. You need to know this. You need to know what are the security factors related to each of the languages that are used here, related to the physical equipment, and especially related to how do all these systems, legacy systems that are in place at the company I'm getting a job at, how do all these systems communicate with each other? Is there one central place in there that handles what they call middleware, the communication between all these disparate systems? That's a very effective point of attack if you're trying to harm a company, because you can intercept every message that happens between all of the disparate systems. You need to know those when you get on the job. Again, it speaks to why when you arrive somewhere, you need to do a tremendous amount of investigatory work to understand how your company works. How does it do business? And how over the years did we translate the business need into software so you can think about it in terms of security, in terms of a lot of other things too. If you ever get called upon to do any sort of design work, any input at all, you're going to need to know, okay, what's the landscape of all of my legacy technology? But we're speaking about security, and if you don't understand the security factors for each one of those, you're not going to make good recommendations. Now, I'm talking to people, I want to step back for a second. I'm talking to people who are going to be going out there as junior developers. None of the things that I'm going over are going to be things you're going to be called upon to make major decisions on or to provide a tremendous amount of input on. But what I want you to be thinking with when you arrive on the job is, what do I pay attention to? What am I looking for? Look, there's so many things you can learn when you get on the job. There's so many different areas of that are fascinating or boring, but you need to learn them. You can spend a tremendous amount of time just becoming a complete expert just about databases or total front-end guy. But this is an area that no matter where you end up, you need to be paying attention to. What does my company do about security? And by the way, if you arrive at a place that doesn't do anything, I would pay close attention to that. And I would be quite concerned about the fact that they don't, because every business needs to be concerned with it. All right, other areas that the developer needs to think with. And this one is, it can be a nightmare. You just gotta know that this is a really important area. Number 4, ensure compliance to governance, regulations, and privacy. In America, companies don't get to decide how they operate anymore in some key areas. As an example, if you have this, IBM bought this company out in Beaverton called Tenants, the place I was working, and they're in the mortgage processing industry. That is an incredibly highly regulated industry, almost nearly as much as healthcare, because you're dealing with people's financial records. You're dealing with an area that was rife with fraud, particularly in the years leading up to 2008 and 9, when a lot of the economic collapse happened in America. Immediately following that, the government put in place bills that are designed specifically to protect consumers, not to mention the fact that anything that involves sensitive private data like social security numbers and people's finances, absolutely there's regulations been around since dirt was invented that just clamp down on how you can release that stuff. You actually need to know about all that stuff as a developer. You don't need to be an expert in it. You're not going to be the one that comes in and does an audit to see how effective are the procedures in place, but you're better be thinking when you're doing your coding, hey, what do we have as guidance to developers to make sure that we're actually doing our work against some sort of a framework that other smarter people than me who know all about information security said, look, if you at least keep these guidelines in mind, we've got a really good chance of keeping our information secure. You need to have that in front of you when you're doing your coding. As an example, out there at IBM, they had, this is really neat, over the period of about a decade, they built up a whole library of code that they built themselves. They handled a tremendous amount of things that were important internally. Things like authentication, making sure you are who you are, logging of errors and routine operations from all the pieces of software that are running, and many other things. Well, when you're implementing information security in your program, you can't just go off willy-nilly and find some really cool library that you found on the internet that does a really good job of providing secure authentication to make sure you are who you are. No, you have to know what the lay of the land is of the company that you use and use their library. You may not like it. You may find that his documentation stinks, or that you can't quite figure out what it's supposed to do, and it was broken 3 years ago, and the patch they put onto it doesn't work really well. I don't care. You use what they said at that company, and you bring your attention, bring to somebody's attention, hey, there might be something wrong with this. These are all factors you need to think of as a developer. Okay, next thing. Know the basic tenets of software security. So these are things like protection from disclosure, keeping things that are supposed to be confidential, confidential. Protecting data from being destructed that shouldn't. For example, there are regulations that sometimes state how long you need to keep certain vital information on record. Let's say you're supposed to keep some certain data for 7 years because the government mandated it, and you accidentally, through writing your code, allow a database table to be deleted that contains only 3-year-old information, not 7-year-old information. You're toast. Okay. Who's making the request? Some of the basic things to consider, that's authentication, right? Authorization. Okay, good, so you are who you are. Are you allowed to do what you're trying to do? This is where it really gets to the meat of, the heart of the matter with you as a developer. These are the things that you need to be looking at when you're actually coding, okay? Do we protect data from being disclosed? Do we protect data from being altered erroneously when it's not desired? Do we keep data available that's supposed to be available and make sure it doesn't get deleted? Do we make sure that people have authorization to actually do what they're doing, make sure they are who they are? And do we build historical evidence as we move along of what actually happened with that program? Who did what, when, and what was the outcome? If we're not building that historical evidence, then we're opening ourselves up to, one, either further an attack, or two, if an attack does occur, the inability to figure out what happened, right? So that's where you come in as a developer, through using proper authentication methods, through building the sections of your code in a really intelligent manner so that functionality that should be delineated by what your role is kept in a role-based area. So that if you're a manager, you're allowed to have everything, but if you're just a customer service rep, you can only access this, this, and this, but you can't access all these things over here. That's you. That's you in organizing your code. Does that make sense? You think with how to organize these things based on who's going to be using it, or are they allowed to use it? This is information security as it applies to you. And so one of the few things here that really applies to you doing your job as a coder, as a software developer. The rest are people things, right? Good. So the other factor, Ensuring the protection of sensitive information. This is not always cut and dry. What is sensitive information? Well, surely someone's social security number is sensitive information. You get a hold of that and you can do a lot of damage, right? But what if you're Steve Jobs, about 10 years ago, and you get cancer? That particular piece of information should be managed very carefully and released to the public in a very controlled manner. Apple's a publicly owned company. You just let that get out without any control, and people can go haywire and dump a bunch of Apple stock and freak out. If, however, you control the release of that in an intelligent manner, you can weather the storm, as they did, and emerge stronger, and now look where they are, the most valuable company in the world. That's sensitive information. Sensitive is a judgment call. And this is another area you as developers need to pay attention to as you go along in your careers. To the degree that you understand the business process at your company, and you understand what the users are like, and how software development is done, all these factors we've covered, to the degree that you understand all of those, you will be in a position to utilize common sense in figuring out what is sensitive information and that you need to protect. It isn't really common sense. What it is hard-won knowledge because you paid so much attention along the way to the company, to all of its clients, to any regulatory things it has to comply with, that when some new piece of information or a question about whether to release something or a question about whether or not to authenticate somebody to be allowed to use a certain portion of the application, when it comes up, you'll have all this wealth of information to be able to go, hold on, we need to look at that a little more closely. Let's not just make it so that anybody can access that. You may not be the one that decides on the exact way to protect that data at that point, but at least you have the common sense to go, whoa, whoa, red flag. We need to look at this, guys. So, further guidance when you're working on your careers as a developer. All right, we're almost done, guys. All right, design software with secure features. Okay, that can mean a lot of things. And none of you here, well, almost none of you, are senior software developers, okay? A senior developer, when he sees that, is going to be able to take that and design the entire architecture for a major piece of software used to handle key functions for a company. You're not going to be doing that when you get on the job. You will rise to that point should you want to. But what you will be doing is you'll be utilizing pre-made frameworks, pre-made libraries of code to do most of what you're doing. To the degree that the frameworks that you use pay attention to creating software that is secure and safe, your job is made easier. One of the reasons the .NET framework is as popular as it is precisely that Microsoft is, at its heart, an enterprise company. They are concerned with the enterprise, with business, with protecting your assets, your intellectual property, with remaining safe and secure, right? So the .NET framework itself is built with that as a primary consideration. So chances are, if you need to build something, and you use the .NET framework to do it, it will force you into using some of the best practices related to information security. On the other hand, if you're operating on the bleeding edge and you're using some JavaScript framework that just got created last Tuesday by a guy in Ohio that now has a very rabid fan base of 5 people, and you're like, I need to try this out. Yeah, try it out on the weekend on your own little home project. Don't try it out on your enterprise project that is going to be responsible for the security of the entire company. Does this make sense? Not all frameworks are as robust. I said the word robust. Write that down, okay? That's the word of the day for me every day. Not all frameworks can be as robust in terms of security considerations. But that's also on you to know your framework and to research it. If you go on the job, whenever you guys get hired and you're on the job and you're asked to use a framework, it should be one of the key things you're looking at that you should learn about is how do I use this framework to implement some of the things Eric was talking about? How do I use this framework? Because it does it a different way for every single framework. You're not often going to be called upon to actually create any of these things from scratch, like authentication, use your logon and all that. Look, there's lots and lots of solutions out there for it. But how safe and secure is that solution? That's your job. You need to pay attention to that kind of thing. And if it isn't, then even if you're junior, it's okay to say, hey, I can't find a lot of data in here about security, and what do we do there? Any other senior developers who go, oh, good question, thank you for asking. Well, here, blah, and they'll turn you on to it. But at least you noticed that the framework you're being asked to use seemed kind of light in the area. So that's one aspect of design software with secure features. You won't be designing a lot of it from scratch. You'll be using a lot of pre-made libraries. pay attention to those. All right. And then develop software with secure features. That basically is do what we're talking about. When you make the software, implement all these things you've learned about. Finally, deploy software. Well, almost finally. Deploy software with secure features. So here's a pretty important point. When you're building something in a development environment, when you're sitting there doing all the coding, things are pretty loosey-goosey in terms of security, frankly. Because as a developer, you don't want to be locked down all the time by having to make sure that every single time you get into your application that you have to authenticate, make sure that you're the right user and all. No, you want to break in and do some work, thank you very much, and not be burdened by all these painful security things. So it's very easy to take shortcuts when you're doing development work and have something that, oh, it works great there, but it's got more holes than Swiss cheese. When you deploy that to the actual production environment, it's vital that you make sure you close up any of those holes. Now, some of you may not have an idea of what I'm talking about, but you will the first time you're building something that's larger in scope. You're like, oh, I kind of want to just log in without having to log in and fool the system into thinking I'm a super user or an admin of this thing. I'm going to do that. I'm just going to bypass the whole login and break in. And it's the right thing to do for getting your job done quickly. It's the wrong thing to do to ship it that way. Okay? So pay attention to that. Finally, educate yourself and others on how to build secure software. Again, I don't know that many of you are going to move into being like information security experts, although who knows? You know, you're going to take whatever path you can take in your careers. But if you as a developer are, let's say, have reasonable attention on this area, not freaked out about it, not all paranoid, but reasonable attention on it in how you do your job as a coder, how you interact with end users and with management. If you think about these factors, you'll be aware when they're starting to be violated. And that's the point where you go, hey, I don't know the word, are we considering security in this scenario? Just that alone can save your company. You can save your company. Because here we are, most of the time when you deal with with software development teams, both project managers and end users, they're all about solving that problem in front of them. And they can get so excited about building a piece of software that's going to handle this big key business case or business issue, and it gets super exciting. And sometimes the last thing on people's minds is, oh, what about the idiot user? What about the social engineering guy who calls in and manages to convince someone on the front desk that there's someone from with our company? What about those guys? You're not thinking about that. What you're thinking about is the real user and how to solve things for them, and that's totally right. But if you lose sight of this, then all these other factors come in. And that's on you. I would say that's on you to pay attention to. No, you have a phenomenal opportunity to help yourself and your company do well just by paying attention and going, hey, this is all well and good, it's a lot of fun, but we better pay attention to security. So, in closing, all I want to say is that information security isn't just using common sense. Like I said earlier, your common sense comes about because you pay attention to these things. You may not get deep dive into them and so freaked out about, oh, we've got to build everything to be more secure than Fort Knox. But you're aware of it. And as you go through your career, you gain more and more knowledge in this, you'll be in a better and better position to advise yourself and others and to imbue your code to be as safe and secure as you can. So, there you go. That's the end of my talk on information security. Thank you.
Thank you.
All right, question and answer period. Anybody want to throw things at me? Well, no, not literally. That's just, want to throw questions at me. Anything at all, about any subject. I don't care if it was this or anything else. And the answer is yes, you can definitely loan me your Apple Watch. That's
After me.
After you, yes. Yes?
So I work in financial advising, and obviously we're dealing with people who obviously secure information. I mean, people have life insurance policies that are worth $1 million. I mean, you definitely wouldn't want somebody getting in there and pretending like they're that person and collecting a death benefit.
Right.
So how great does encryption work as far as securing computers, as far as securing our network? Just because that's kind of the thing that they go around, is encrypting your computers, encrypting your phones, making sure you're not accessing our, it's called FieldNet, making sure that you're not accessing that on a computer that's not encrypted so people can't get that information.
Right.
Is that a way of securing? I mean, is that what you guys are talking about, or is that a little bit different?
No, yes, it is in that area.
Yeah.
And this is my observation in the financial arena, is that it's one of the main reasons computers were invented, is to handle this. In fact, some of the first computers were designed to process tax records and census records, like that whole area in there, right? Very, very private data, right? So from very early on in the computer industry, security of that kind of information has been paramount, and there are, I won't get into a bunch of misunderstood words on this, but almost any way that you process data of a financial nature splits out the data from the actual specific, who it's tied to, like, oh, I'm Bob Jones and here's all of this, and encrypts both of them, right? So in terms of like code libraries and tools that developers can use, there are very few unsafe ways to do it. You'd have to really try to make it so that that information was very easily found. But social engineering and dubious human methods, that's where that kind of area is open to a lot more danger.
Okay.
So those kind of environments are ones where it's real important that everybody, like everyone in the organization, just be aware of the fact that that you actually, unfortunately, you can't trust everybody who's calling in or sending in an email or whatever. And by the way, the email phishing attacks can be very effective, very realistic. You've seen this as well, Brent, I'm sure, that you can get an email that you actually think is from your internal HR. It looks exactly like something else you would get internally that you might get every single day, but it's not. It's from an external source. It's got all the right images. It's got all the right little things down at the bottom. The signature line looks the same, but it's asking for something that just why would you need to know that? You know? So there are unfortunately people that are quite robotic, and we've worked around them before. Developers particularly they aren't really that way, being robotic. What I mean robotic is, oh, I got an email from HR, therefore I must respond. Here's my data. Click it off, without stopping to think, well, that's why would they really need that, right? So to fully answer your question, it really is more of a people and a social process that I've seen be more of a danger in that arena. Although, who knows? You get some small company that's creating financial software from the ground up, they could do it pretty poorly. So, make sense?
Yeah.
Good.
Yeah, and I guess in the financial industry, if you're under like, I think 80 million in whatever you want to call your collective money from your clients, you don't have the standards that the bigger companies have. And I know this because I spoke to a company that is under 90 million the other day, and they were worried about their security. So, and I found out from that call that they don't have the same regulations in the financial services industry as companies that have over 90 million. So it's up to them to keep their data secure.
This brings up a good point, and I'll get you in just a second, Brent. This is expensive. Implementing all these things is expensive in terms of, it takes time to really analyze. Let's say you're in charge of information security for a large company. It's not a one-man job, and it takes time to dig in and figure out what are the points of attack, what are the factors involved. It takes money to implement the hardware and the software involved. It adds significant overhead to a company's operation to actually do this sanely. But if you don't, you're a Sony. If you don't do it right. Brent?
I'm just going to tag on if you don't mind.
Of course.
So in a situation like that, I wouldn't personally attack you. I would attack one of your vendors. Okay? You look at Target, you look at Home Depot, they personally were not hacked. It was a third-party vendor that didn't have it. So that's why you have regulations and compliance like Sarbanes-Oxley, and there's these types of compliance regs so that companies doing business with other folks, at least there is a minimum level of security in order to do business with us. One of the misconceptions is that security is seen as sort of like a police force. We're locking everything down. And that's actually not true. Security is an enabler. If you are very well secured, it enables you to have other relationships with other businesses and corporations. So the more that you're secure, the more that you can do business. The less you're secure, the less you will do business. So you have to think of security as an enabler. And so a situation like that, I wouldn't be worried about the hacker on the street. I'd be worried about all the vendors that you work with. You work with a mom and pop shop, okay, if I can hack them, I now have you.
That's a really good point. It's like a parallel you would think, you know, in terms of like common phrases is, you know, a chain is only as strong as its weakest link.
That's right.
And that applies, because that actually is how Target got brought down. It was some, you know, construction or renovation or cleaning sort of third-party company that did services for them, but as part of it, had access to all of their financial data, including credit card information. And their security was horrible, and Target's was good, but it was only good inside Target, right? So, very, very good point, right? Very good point. Other questions? And again, you go far afield from security if you want to ask me. Yeah, go. What's his name again?
Brett.
Brett?
So, I'm not quite sure like how to phrase this without kind of going back a little bit, but my question's in authentication.
Yeah. Authentication, that you are who you are.
Right, so I'm going under the model that I think Bruce Schneer laid out 25 years ago, talking about the only three ways that we've had since the beginning of mankind to gatekeep is
Right.
essentially three things: what you know, what you have, or who you are. So who you are would be like when I walk past the front desk and say, "Hi, Bill," and he says, "Hi, Jim." The reason he doesn't call security is because he recognizes me,
Right.
which is going to be a variety of things.
Right, that's what you know.
Computers, like, as developers, computers don't have that. We like to pretend they do sometimes. I mean, what you know is, of course, the password, the combination to a mechanical lock. What you'd have would be a brass key or something that you swipe past a scanner or something
Your
like
phone.
that for your phone. So we tend to associate biometrics with who you are, but, you know, as you say, somebody can take your thumb or your iris if the information's valuable
Yep.
enough. Those are things, but I guess the question becomes, as developers, how can we move beyond these first two genres of authentication, what you know and what you have, and really get into who you are? There's been some interesting ideas of how human beings do this. We judge somebody on the phone by the timbre of their voice, how loud they are, you know, vocabulary usage.
Right.
If all of a sudden I start dropping likes in my phone conversations, my friends are going to go, "Hey, what's going
Yeah.
on?" So how do you, you know, who's, I guess, working in this area, and like what would you say is the platform to begin moving authentication away from those insecure, what you have, what you know, into who you are?
This is a neat question, and it jumps into an area that I'll never get to work in. There's a number of areas that I'm not going to get to work in. Things like artificial intelligence, compiler design, and things like this. Basically, prediction of human behavior is part of what we deal with, right? And analysis of the physical universe and drawing conclusions from your analysis of the physical universe is part of what you're talking about. And here's the thing. I'm going to answer that, but this is a point to all of you as developers. There's amazing work being done in hundreds of different areas, all related to technology at any one point. There's fantastic things being done in the whole biometric area. There's things in language processing. There's things in, you know, speech recognition, pattern recognition, all sorts of stuff, right? Very few of us are going to work on that. How many people got to work on the Oculus Rift? Who doesn't know what the Oculus Rift is? You know, your virtual reality goggles, right? So, what an amazing thing to work on, right? And this whole Magic Leap technology that, you know, if anybody saw the video game demo of that about a month ago that I was running around showing everybody because I'm a geek. Yeah, you're basically fooling the body's perceptions and making it think there's something in the physical universe that isn't there. These are unbelievably cool areas to work in that very few of us will get to work in. It's just how it goes. You can still have a phenomenal living as a developer, but you don't get to work on those really cool things. Some of you will. That's awesome. So the point of view I've always had as I saw those things happening is that they're happening on the forefront. They're out ahead of us by 2 to 5 years. And as a developer who's kind of a technician, you know, just working with the tools that are commonly available to build these tools that business uses, I'm not going to get to feel the fruits of that labor for 2 to 5 years. But I'm looking forward to them. I don't get wrapped up too much in them because it really is out there on the edges. Does that make sense? That's I'm not telling you that's just my personal point of view about that is that stuff's awesome, but I don't feel that as a developer for a few years, kind of thing. Now that said, I do pay some attention to it, and there's a couple companies in Israel. Israel is an amazing country for software development. They are absolutely cutting edge in terms of things like data visualization, language processing, like unbelievable stuff is done out of that country. Don't know why it turned out that way. They have great developers, and they're almost an R&D kind of machine in a lot of ways, research and development, right? So you're like what you're talking about there in terms of how do you make a computer think that it can actually tell who you are, right? How do you give it that ability when it isn't really an ability? Computers don't have abilities. They have very precise programming. It's not an ability. Right? Well, that kind of work bridges this line between strictly technology and the humanities. What makes a person a person? What is communication, ultimately? How is it that thought works? And there's some really wild things that are going on in that space. Oddly enough, they're driven by the war on terror. As odd as that is. Some of the most fascinating work that's being done on analyzing who people are and what their intentions are, and are they who they say they are, has to do with a bunch of pattern recognition and algorithms based on trying to filter through a crowd and find out who's the problem. Okay. You're awesome. You're awesome, right? So that's an area to look at for where is that research being done. I think it's a horrible testament to the state of this civilization that that's where that kind of work is going on, but that's my personal opinion. That's where you'll find a lot of that stuff. You'll also find it in the Defense Advanced Research Projects. DARPA, what does DARPA stand for again? Agency. Defense Advanced Research Projects Agency. Unbelievable stuff being done there because, again, they're actually trying to bridge that gap between technology and the human being. And it's a fascinating area. It isn't an area, like I said, that we bump into very much on the job. But that's where I look for that kind of stuff when you're going to want to deep dive into it. Does that help at all? And if there's another question, go for it. I'm fine.
Yeah, it does, but I guess like I'm looking for areas where we can bridge stuff that's available to us as developers. Like I see you guys don't do like Apple development stuff, but for example, okay, so HealthKit on iOS is an area where we tend to think HealthKit, okay, this is how my watch is going to monitor like my pulse and my blood pressure and all of this. And if there's a problem, it's going to contact my doctor, or it's going to allow me to track my glucose levels if I'm a diabetic.
Right.
But coming back to security, I would go, well, if I wanted to create a really secure app for this device, and you take this off my wrist and put it on, and HealthKit notices that my systolic, I don't know what your blood pressure is, but let's say that my systolic pressure went up 30%. It's not biologically possible in a 3-minute span to have your blood pressure go up that high. So it triggers an authentication mechanism that says, this is a different wearer.
Right.
And that information overlaid in a lot of different areas would give you a much more accurate picture.
Yeah.
Just like as an idea off the top of my head. But, it just, I guess I'm wondering, like, how do we as developers work to see how we can use tools that are targeted for a specific purpose and cross-blend them in areas like security, for example, in an effective way?
I don't know if I can answer your question without a specific for instance. And I'm not trying to be deliberately obtuse at all. I'd have to have, because I'm obtuse enough without being deliberate about it. I'd have to have a for instance. All I can say is that when you, until you're educated in computers, you can think they're magic. Have you guys noticed that? Like, oh, the computer knows who I am? How does it know who I am? That kind of thing. There's even one of the books we use in the course called But How Do It Know, about computers. And the only place I can go with that is in terms of the thinking process of being a developer and designing software. If you know that essentially all you actually have is a machine, you'll never make the assumption that the computer knows anything. It absolutely does not know anything. It doesn't even, like you can say, it knows what you tell it. It doesn't even strictly know that. It's just given data and told what to do with that data. Any significance about what that data means is purely invented, or it belongs in the human element. The computer doesn't think it means anything. It's got no personality. It's just a machine, right? So when you're doing work like that, you're being given whatever kind of tools there are in terms of the syntax of the language and how to interact with whatever biometric readings or whatever it is, right? All of those All those are just mechanics. What's gonna be important is you actually going, okay, all right, so those are the tools I have to use. How do I make the computer act as if it can actually perceive the physical universe and know what things mean? How do I make it act as if it does, knowing full well that it doesn't? And then it becomes your tool, and you use it the way you want to. Again, without a specific for instance, I can't go any farther on that.
It's a helpful paradigm.
Yeah. Other questions, anything? You guys have been great to sit around this long. If you want to end off, that's fine. You want to leave, I'm totally cool. But if anybody's got any questions, I'm good for it. As you can tell, I can talk for a while. Okay, good. Awesome. Well, thank you very much for being here. Please feel free. Food, socializing, all that kind of stuff. I'll be hanging around for a while. Anybody wants to talk to me? Thanks.
All right, thank you.
You're welcome. Yeah. Yeah. Yeah.
Oh, yeah.
Yeah.